Hi, Algebra 2, we're back here still dealing with polynomials. We're going to do something that sounds horrible, synthetic division. Okay, synthetic division is a strategy that we can use to divide a polynomial group by another polynomial group. Okay, now this is a strategy, I'm just going to say this right at the beginning. This only works in certain situations. Okay, you can only use this strategy. Okay, so you can only use this strategy if the divisor, the bottom of the fraction, is linear, which means it has just an x to the first as its highest exponent. Okay, if it had an x squared, or if we would call that a quadratic, you couldn't do this strategy. Okay, so just know that this works a lot of the time with the problems that we see in Algebra 2, but sometimes if this is an x squared at the bottom, we have to use something else. Okay, but I do like teaching this to you because I think it's the easiest strategy for sure. And again, like I said, you can do most problems using this. So just doing this, okay, when you think like long division, right, we have that big like check mark looking thing and it's a huge thing. Synthetic division, we set it up using almost this like half like box shaped thing. Okay, so that's your start right there. Okay, now here's what we do. We're going to divide this whole group by x plus 2. Again, normally if we were dividing this by like a single term at the bottom, what we would be able to do is divide each term at the top by that single term on the bottom. Okay, and it would work out really nicely. But with a group on the bottom, a polynomial group, we have to do something else. We have to account for the fact that it's a group and it's not going to divide as evenly. Okay, so that's what synthetic division is helpful with. It gives us a way to divide. Okay, now here's what we do. Here's the setup. Okay, so this bottom, the bottom of this, okay, x plus 2. You remember in the other video, we talked about how when we have this would be called a linear factor group like this. When we have a linear factor group, like this x solution that would come from this is x is negative 2, right? Because if we set it equal to 0. So what we do first is we kind of, basically it's just switching the sign of this bottom, okay? And that number is going to go on the outside, okay? Because that's the number that that's the key number that I'm dividing by, okay? Okay, so you switch the sign of that bottom number down there with the x, okay? And then what I do in the box here is I kind of write what all my coefficients are of all the terms along the top. Okay, so we would start with 1, because that's 1x cubed. And I don't write the x, I just write the numbers. That's what's nice, is that with this, we're just dealing with numbers, not necessarily dealing with variables as much. Okay, so I have 1, I have negative 14, I have 51, and I have negative 54. So I have these 4 separate numbers, okay, in this box, and this negative 2 is here, okay? So here's what I do. It's a cycle. It's a rotation, this process, okay, this synthetic division, okay? So here's what I do. Here's the process. I start by bringing down this first coefficient, okay? And it's going to be 1 for the problems that I'm going to show, but sometimes it's not 1. But whatever it is, you just bring it down, and that just goes right there. So you start the process out by bringing down the 1. And what you could write here, you could write a little multiplication sign here, because what's going to happen is it's going to be this outside number times this 1. Okay, so negative 2 times 1. I would multiply those, and I would get negative 2 as an answer. So negative 2 times 1 is negative 2. That number goes right there. Okay, and then with these, I'm going to add. Okay, so negative 14 plus negative 2 would be negative 16. And then the cycle kind of starts over. So I brought this down by adding, okay? And then I multiply. Negative 2 times negative 16, positive 32, positive 32. And then I add, so I'll get 51 plus 32 would give me 83. And then I'd start the cycle again. I multiply. Negative 2 times 83, I would get negative 100 and, okay, so I would get 166 there. And then I would add down here, so if negative 54 plus negative 166 ends up giving it negative 220. Okay, so I have all these numbers. Now what does this mean? Okay, so what happens is, again, this is a way of kind of visualizing the division that happens between these. Okay, so when I'm dividing, okay, so look, this is actually important. My biggest number, or my biggest exponent rather, is a 3. Okay, and what I'm dividing on the bottom is just a linear x, or x to the first power, okay? So I actually do that, and that kind of determines for me what this value is going to be right here. So this is going to be 1, and these are all also going to be coefficients, okay? So it's going to be 1x squared, okay? So the highest exponent, I divided it by x to the first, so I can kind of subtract those exponents, 3 minus 1 to get 2 here, okay? So that determines the first variable there. And then I just go down the line. It's going to go down from there. So x squared is going to be minus 16x to the first, or just plain old x, okay? And then this will be plus 83 as a constant, or without any x's, okay? Now you might be wondering, like, okay, well, if there's no x's on that, you can't really go like lower. So what happens here? Okay, now this last part, right? You might remember with doing long division in like elementary school, where when you divide something, sometimes you have what's called a remainder, okay? And that's what this is. It just means that this doesn't divide like exactly evenly into this, okay? Which means I have a remainder left over, okay? So how I would write that, here's what I would do, right? So all this divided evenly. Okay, I got this as an answer, but then this part, what I would write is minus 220 over my original divisor, the original thing I was dividing by. So this x plus 2. So that would be my full answer. That's what I get as an answer when I divide this big group divided by this smaller group. Okay, I get this group as an answer. Okay. Now you might still be iffy on that process. So let me just show it 2 more times and hopefully you'll be solid after that. Okay. So looking at the first of these examples, we have x cubed minus 57x plus 56. Okay. So again, we can set this up the same way. Okay, we have our little half box thing there. Okay. Again, what's on the outside is the number that's on the bottom here in the divisor switched. Okay, the sign is switched. So if it's minus 7, it's going to be a plus 7 out there, or positive 7. Okay. And then from there, continuing to set up, I have my coefficients. Now you might think, okay, I have 1, negative 57, and 56. But if you look at your x's, this is really important, and it's really easy to miss this. X cubed, that's a 3 exponent. And then it goes right to x to the first, right? 1 exponent. We don't have an x squared term. So it doesn't appear that there is an x squared term, okay? What we would actually say is that it was 0x squared. So it's really important that if there's not an x squared term written there, that you fill in that space with a 0, okay? So you got to be on the lookout for that with any missing x terms. As you kind of go down from the highest one, you fill in that space with a 0. Otherwise, it's going to really throw off your answer. Okay, so I have 1 as the x cubed coefficient, 0 as the x squared coefficient, and then I can continue negative 57 and then positive 56. And then I start my cycle here, right? I start my cycle, and that begins with just bringing down my first coefficient of 1. And then I'm going to multiply. Okay, so 1 times 1, sorry, 7 times 1 is 7. And then I add. 0 plus 7 is 7. Okay, and then I continue from there. 7 times 7 is 49. And then I would do negative 57 plus 49 would be negative 8. And then I multiply 7 times 7 times negative 8, negative 56. And then I add 56 plus negative 56 is 0. Okay. So then let's write my answer and we'll talk about what the 0 is, because, right, remember that 0 is in the remainder position. Okay. So my answer to this, again, similar to the first one, my highest exponent here was a 3, and I divided it by an x to the first. Okay. So that means that my highest exponent in my answer is going to be 2, right? Reducing this exponent by 1. So my answer is going to be x squared plus 7x, right? These is my coefficients, and then minus 8. And then I have this remainder of 0, right? So compare that to the last one, right? The last one we had a big remainder, and that was just kind of my answer. And that said that meant that this did not divide evenly. But if I have a remainder of 0, that means that this does divide like perfectly evenly with this one, which is nice, okay? Which means that this group is perfectly divisible by the top group. So what a zero remainder tells me is that this top group is perfectly divisible by this smaller bottom group, which is great. And that means I don't have to write this extra term here with the divisor on the bottom in my answer. I can just go with this as my full answer. And then I saved the biggest one for last. Look at that guy. Okay, so with this one, I set up my big box. I'm going to make it bigger here because this is a massive group on the top. Okay, and then again, my bottom number here, +4. I switch the sign, I put that on the outside, -4. And then from here, I just go down the line, right? So my first coefficient's 1, my second coefficient's -3, my third coefficient's -28. Okay, now stop right here. Okay, let's check our exponents. 5, 4, 3, 1, right? We're missing 2. We're missing 2 again, just like the top one. Okay, so again, it's really important that you make a note of that right there we're missing a exponent. So again, it's going to throw off your answer entirely if you don't see that and put a 0 where that would go. Okay, and then you continue from there, 5 and 10. Okay, and then I start my process, my cycle. So bring down my 1, multiply, -4 times 1 is -4. And then I add -3 times, or sorry, -3 plus -4 is -7. Okay, and then I multiply -4 times -7, +28. So then I would add -28 plus 28 is 0. Great. Okay, so what does that mean? Again, that throws kids off sometimes, and you're like, okay, am I done? No, you just keep going. -4 times 0 would be 0. And then I would add, and I would say, okay, 0 plus 0 is 0. And then I would multiply again. I would see, okay, -4 times 0 is 0 again. But then I would do 5 plus 0 is 5, okay? And then my last step, -4 times 5, -20, okay? And then I would add 10 plus -20 is -10. Now we have all these values in here, okay? I have a couple zeros, but let's again break down what this is going to be like in my answer. So x to the 5th, okay? And I divided by x to the 1st. So my first coefficient is going to be x, or my first variable, the degree on that is going to be a 4, okay? So my answer is going to be 1x to the 4th, right? And then I go down the line from there, minus 7x cubed, okay? And then I have these two zeros here, okay? So this normally would be 0x squared plus 0x. When I have zeros in those positions, it's not wrong to write them. You can write plus 0x squared plus 0x. But again, that doesn't, or just like how up here when it was 0x squared, it didn't write it in the group. So you don't have to write zeros in your group either, unless it's helpful for you, okay? So 0x squared plus 0x, so I have this plus 5 constant. And so I'll write that. And then I have this minus 10. Again, that last number is always your remainder, right? So that's going to be minus 10 over your divisor of x plus 4. Okay, so that would be the full answer to this question. Okay, guys, so that's a little bit on synthetic division. I hope that makes sense to you guys. It's a weird process, but makes dividing by these smaller groups a little bit easier. Okay, so thanks for following. Great job.